All right, we are back with I believe this is part 5 of the drum roller project for the Stellar Robotics 2018 CAD class. We're going to go through and we're going to add mounting holes to all of our sheet metal parts. We're going to fillet sharp corners, or I should say radius sharp corners, add some lightning features, and then in the next video we are going to go through and add all the fasteners. I'm going to try to, these videos are being way longer than I'm intending, and we're going to end up with 6 videos at like 45 minutes a piece. This is going to like I don't even know what is that, 5.5 hours, is that what that is? 4.5 hours. I can do math. Gosh darn it. All right, it's 7 o'clock. It's past my bedtime. All right, that's a joke. Let's start on the main structural components because we know how we want to do the mounting holes. We want to just have rivet holes 0.196 in diameter in a line down each of the 3 edges with the overlapping flanges. So let's start with the outside parts. Remember that this part and this part are, oops, not that part. This part, basically the 2 outside parts are the same part, just 2 instances. So let's just open one of them. Oh, I should close the rubber part. All right, so let's go through and let's add a row of holes on the top, and we'll just make the whole distance so it goes through the bottom flange too, because we know that we want them to be the same top and bottom. So let's create a sketch on the top face. Let's project. They're going to be they're going to start ½ inch in from this outside flange. So it's going to be, we're going to project geometry there. We're just going to place a point down. Now we can't use the whole center point trick because the line starts here at the beginning of the radius, so we're just going to use a dimension. We're going to dimension it ½ inch in from the outside. Now this is not going to be a ½ inch in from this flange, but that's okay. We wanted a ½ inch in from the outside of the feature. And then it's going to be a ½ inch in from the end of the part. Finish the sketch. This, like I said, this is going to be a rivet hole, so it's going to be 0.196. We don't want the termination to be distance thickness. We want termination to be through all so that it goes through the bottom flange as well. Sometimes you can do that on some sheet metal parts and sometimes you can't. Just you need to make sure that you know if you can or not. In this case we can. So click OK. Then we're going to go to a rectangular pattern, click on the hole, click on direction 1, click on a line running in this direction. We're going to set the hole spacing to be ½ inch center to center. Then we're going to just type in a number. We don't want that. We want 9. I need to investigate this. I may have picked the wrong part here. Click OK. Oh, I know what I did. Yeah, okay, so this is an issue that I caught in the in-person class, and then I wondered if I had done it wrong in the video, because I recorded the first 2 videos before the CAD class, before the actual class session, and then I'm recording the rest of these after the class session, and so we did this a little differently in the actual class than I did it in the video. So let's go, we need to fix this, so let's go to the face and go to sketch 1. Basically, we subtracted a 1/16 of an inch here, and we did not subtract a 1/16 of an inch here. In the CAD class, I had us attach a dimension from here to the end, but we're just going to subtract a 1/16 here, and that'll be okay. All right, so now this should be ½ inch from the end of the part, which is how it should have worked out. Okay, now let's give this a save real quick. I think if we go back to our assembly, now we've got this issue where this part's sticking out. So we need to edit this part, and we need to edit this part and do the same thing. So let's just do this real quick. This is just fixing a mistake that I made. So go back to the face, edit the main sketch, edit this overall dimension, minus a 1/16, finish the sketch, give it a save, close the part, we'll come back to it. Now that's good. These are flush again. We got to do the same thing for this one. So open the inside part, edit the main sketch, add, subtract 1/16, give it a save, close it. All right, we're good. All right, so let's go back to this part. Now let's add the holes on the end here. So let's do another sketch. It's going to be the same deal. So we're going to place a center point. We're going to project, turn on construction geometry, project this edge and that edge. Do a dimension from there to the center point. It's going to be 1/2 inch. And from the back to the center point is also going to be 1/2 inch. You cannot dimension from out here. You've got to dimension from these surfaces, because it's not 1/2 inch from here. It's something else. So finish the sketch. We're going to do a whole feature. Termination is going to be distance again. There's no reason to go through all. Through all doesn't hurt anything, but there's no flange on this side, so there's no reason to do it. Then that's going to be what we want. So click OK. It's still a 196 diameter hole. So we're going to do a rectangular feature again. Click on the hole, pick a direction, pick a line that runs vertically. Now it's wanting to pattern up. We want to pattern down, so you click these little like curvy arrows to flip the direction that you're patterning. Spacing is going to be 1/2 inch, and we should get 4 holes. Yeah. So click OK. All right, so that's good. We're not going to do the lightning holes just yet. We're going to do that last, but we are going to do the fillets. So let's click on corner round. I like 1/4 inch fillets. Are nice and big if I can use them, and in this case these corners aren't actually accomplishing anything, so let's just fillet all the sharp corners in the sheet metal part. Okay, and click OK. So that looks nice. No sharp corners. It's easier on the laser to cut nice big radiuses anyways. Give that a save. I need to look at the flat pattern real quick because we had to make a change to this like edge corner thing here. So let's go up here to create flat pattern. Yeah, no, it does what I want it to do. Okay, so that's fine. Alright, so save that. We're going to close that out. Alright, so now essentially we need to put holes in this part here that match these. So we're going to do the same thing we did before, except we got to subtract a 1/16, so we can't do 1/2 inch in from the end. We got to subtract the material thickness because this part is inside of this part. Does that make sense? Okay, so we're going to open this interior part here. We're basically going to go do the same thing we did before. So create a sketch on the top, create a point, project construction geometry of this face and this face. I gotta edit that corner again. Alright, so dimension from here to here is going to be 0.5 minus 0.625, right, minus the material thickness. Same thing from the end of the part to the hole. Okay, that's a 7/8 or 0.4375. If you want to type that in manually, you absolutely can. Alright, so finish the sketch, create a hole. The diameter is going to be 1.196. The termination is going to be through all, so we're going through both legs of the sheet metal part. Then we're going to go back to our rectangular pattern, pick a hole, pick our direction. It's going the right direction. Spacing is 1/2 inch, and we should still have 9 holes. And this hole should be 1/2 inch on center from the end of the part, which it is. And actually, now that I'm thinking about this, we actually could have dimensioned it from this side and patterned it the other way. Then we wouldn't have had to subtract that 1/16 of an inch, but it's kind of a wash either way. Alright, so just want to make sure. Yep. Oh, why did I do that the way that I did that? That's not what I wanted to do. Okay, I made a mistake. So go back to hole 3, go to sketch 5. This needs to be 1/2 inch. I don't need to subtract. It's just from the end. I wasn't thinking. Okay. You'll see why that is here in a second. So let's create the end holes here. So we're going to create a sketch. Place our point, turn on construction geometry, project the end and the back. And from the center point of the hole to the back of the part is going to be 0.5 like we just did. And from here to here is going to be 0.5 minus 0.0625, or 1/2 minus a 1/16, which is the same as 7/16 or 0.4375. Press enter, finish the sketch, go to the hole, set our termination to distance, click OK, go to the pattern feature, click on the hole, pick our direction, flip the direction, set our hole spacing, set our number of holes, click OK. Alright, same thing as before. We're not going to do any lightening. I'm not even sure we're going to bother lightening this part. This area is so small that I don't think we're going to waste our time with it. If this were an actual intake with a longer piece, we could, but there's not a lot of room here to do anything. So corner round, 1/4 inch radius is fine. Pick all of these corners and click OK. Now I need to check this corner because this looks like it's different than the other part. So save this and go to create flat pattern. Nope, it's okay. Alright, so that is fine. Alright, so we're done with this part for now. Let's close that. Actually, let's go ahead and just call this part done. We're not going to lighten this part, so this part's done. We're not going to do any more modeling on this part. So let's go ahead and set the color to blue wall paint glossy, which is the color that we just use for blue. It's one of the Inventor default appearances, so it's what we use. Save and close it again. All right, like I said, parts that we're actually done modeling that are custom parts, we just set them to the color they're going to be painted because it helps us figure out what needs to be done. We've still got lightning work to do on these outer parts, so they're not done yet. All right, so let's do the holes for this part here, which is exactly the same as this part. It's just we've got to do it again because we copied them. If you were really confident in your design, you could have done the holes before you did the save as, but I wasn't confident enough to do that, so I wouldn't advise it. But you can see that these holes line up. If these holes do not line up, you need to do some more work to make them line up exactly right. If they're off by a little bit, you need to fix it. It means you made a mistake somewhere or you typed in a dimension wrong. Chances are the offsets are wrong. It's really, really easy to do, but just make sure you get them perfectly lined up. Otherwise, when you start laser cutting stuff and putting stuff together, your holes don't line up, your rivets don't go in tight, and drilling out holes tends to make your rivets not hold as well because the holes get a little bit bigger. So anyways, we opened this part. We got it open right here. We're going to do this whole process again. Point, project our construction geometry from the end. Remember, this is an interior part, so this is dimension here is going to be a 1/2 inch, and the dimension from the end is going to be a 1/2 inch minus a 1/16. Finish the sketch, go to the hole feature. Our diameter is 0.196. You can type it in this little floating thing, or you can type it in the box there. Termination through all, okay. Rectangular pattern, pick the hole, pick our direction, set our spacing, set the number of holes, click OK. Create a sketch on the end, place our point. Same process before, project our construction geometry. Dimension from the end is going to be 0.5 minus a 1/16. Dimension from the back is going to be just a 1/2 inch. Finish the sketch. Hole. Termination is going to be distance. Click OK. Rectangular pattern. Hole. Direction. Flip the direction. Set the spacing. Set the number of holes. Click OK. Alright, if you get in a groove, you can do all that stuff pretty fast, and it doesn't take you very long. Click corner around and pick all the corners again. I'm going to create a flat pattern and check this again. Basically, I'm just looking to make sure that this is one of the bend extents, so basically the curved radius part's going to start here, and I just want to make sure that there's a nice corner here. If that's not the case, you fix that by going to your flange feature, right-clicking on it, going to Edit Feature, going to Corner. I've got Tear selected. If you want, you can use Default Trim to Bend. We used, I believe we used Linear Weld. Actually, no. Yeah, I think that No, we didn't use that. Anyways, we're using tear here. That works fine. So, yeah. All right. So tear is what you want to use. Anyways, give this a save. Close it for now. All right. So now we got kind of a tricky thing we got to do. Basically, we've got to line these holes up with the existing holes. So we're not gonna add new holes. We're just going to make these holes in this bracket here line up with the holes in the structure. Sometimes you can do that on design, sometimes you can't. In this case, we got plenty of room. So it looks like we're kind of right in the middle. We're off basically. So let's measure. So we know the holes in the structure are. No, I'm gonna not go that route. Okay, so we know the holes in the structure are 1/2 inch apart. The holes in this part are 1/2 inch apart. We just need to shift it, and if we can add a 4th hole, which it looks like we can, we're going to add a 4th hole. So basically, let's figure out how far off we are. So we know that these holes are 1/2 inch apart, like I said, and so if we know how far this hole is from the end of this bracket, now remember, we're not concerned about the end of this flange. Ignore the end of the flange because the end of the flange is in a weird position. We're concerned with the edge of the part here. Okay, so we're going to do all our measurements to that, not to this flange. If we know the distance from the center of this hole to this flat surface here, just measured like perpendicular to this flat surface, then we'll know what the distance between the next hole is, this guy that's kind of hidden right under here. We'll know how far off we are. So let's get our measure tool. Let's pick this circle and pick this side face. So the center distance is 0.2579. And we knew this was going to be kind of a weird number. This is to be expected. It's going to be something weird because the distance between this shaft and this gearbox is 51 millimeters. So we're kind of like mixing metric and English or imperial measurements, which is going to give you weird non-fractional, non-metric, non-English numbers that you're just going to have to use an exact decimal equivalent. So 0.2579, which basically means that the first hole, as measured from this line that we've got right here, that's even with this face, that first hole is going to be basically a 1/2 inch minus this. So it's going to be about a 1/4 inch, but not exactly a 1/4 inch. It's going to be about 0.08 off of a 1/4 inch. So let's exit out of that with the escape key, open this part up here, and we're going to edit this hole. All right, so what we're going to do is we're going to get rid of this 1 inch dimension. Like I said, we had to do this a different way. And actually what we're going to do is we're just going to get rid of this line entirely. So just delete that line, and we're just going to redimension this point. So click on the dimension tool, click on that construction line up there, dimension to this, 0.375 is what it should be. Now, we know that we're measuring from this edge here, so we're going to project that edge real quick. So we're going to go down here and project this edge. Now, it just happens that this line right here, this line here, is even with that edge, so you could use this edge too if you wanted. It really doesn't matter. Just make sure you get the edge that you're actually caring about. We don't care about this here. All right, so I'm going to dimension from the edge of this to this, and it's going to be 0.5 minus 0.2579. And we're going to OK that, finish the sketch. That's going to shift it over. We're gonna edit our pattern and add one more hole here just because we've got the space for it. It'll also look better. So double click on the rectangular pattern. Instead of 3 holes, let's do 4 holes and click OK. Alright, so that's good. Let's give that a save. Alright, so we can see that these line up nicely. You'd want to use slightly longer rivets to go through all these pieces of metal, but that's okay. Alright, so now we got to do that the same on the bottom. Now, the difference here, well, let's just, yeah, so we know it's going to be the same. The difference is the dimension's going to be on the other side. So let's just open this part here and edit this hole's sketch. We're going to delete the line. Now, the only difference here is that we actually need to put this hole over here, and we're going to have to reverse the direction of our pattern because this part's rotated, so it's upside down. So let's do a dimension. It's going to be 0.375, and from here to here, we're going to go ahead and use that, is going to be 0.5 minus 0.2579. Whoops, 2579. Yep. Finish the sketch. That's okay. Basically, it was just telling us now it's trying to pattern in this direction, and the hole is off the part. So we just need to edit the pattern, flip the direction to go the other direction, change it so that we've got 4 holes. Click OK. Save that. And our holes should line up in the bottom. They do. Alright, so we've already got fillets on this part, so we don't need to do that. Okay, so those are all our mounting holes. That's everything. The bearing blocks are mounted, the gearbox has mounting holes, the brackets have mounting holes, the structure has mounting holes, all holes are done. So now we're just going to go through and we're going to do some lightning, and then get everything colored the right color, and then in the next video we will add fasteners. So let's figure out what we're going to lighten. So we already determined we're not going to bother lightening this part because there's just not a lot of meat here to remove. We're going to do kind of a truss pattern in this large rectangular area here. We're going to do that same pattern here, and then obviously this part here is the same as this part here, so those will be the same. In addition, I really think we should take some weight out of this. I think we'll just do like 2, maybe 3, like just half-inch holes. You're not going to remove much weight, but it's good to get in the habit of, if you've got large flat surfaces that aren't adding much in the way of strength, add some lightning holes. It's just a good practice to get into. So let's actually start here because it's easy. So let's open this up. Now we're going to create a sketch, and I'm not going to use the whole feature here. Now the reason I'm not going to use the whole feature here is because I want to be able to see where the hole is and how big it is, because we're taking weight out here. We're not adding a hole for the sake of putting a screw through it or a bearing in it or something like that. We're creating a hole just because the round shape looks nice. More importantly, it will not compromise the integrity of our material. If we did a square here instead, the corners act as stress risers, and then when basically there's going to be tension on this belt, so it's going to be pulling this bracket to the side, basically. And then basically we need this flat face is going to be taking that load. So if we had squares in there, the bracket would be more likely to fail. Now, in reality, there's not going to be a ton of tension on it, but still, we want to make sure that there's no sharp corners that could cause a failure of the part. So I'm going to create a circle. I'm going to dimension this. It looks like we can probably get away with a little bit. Actually, yeah, I like half-inch. We're not going to be able to take much weight out here, but let's create a construction line so that we can do 2 of these. Do another circle. Oops. I'm going to select that and turn off construction geometry. Alright, I'm going to center this line using a vertical constraint to the origin so that this is kind of like symmetrical. Basically, you can't get a hole too close to a bend. So in this case, can I actually do that? Minimum distance is 1/4 inch. So really we need to move this away some. So let's just dimension it right about there. Sure, 0.7 works. Then let's just dimension the length of this line to be 0.8. Let's make these a little bigger, 0.6. And I'm actually just going to select this and click on the other dimension to set these 2 dimensions to be equal to each other. Alright, so finish the sketch, use the cut feature. Let's look at how that looks in the assembly. Yeah, that looks great. That'll be good. Okay, so we're done with this part, so we're going to set the material or the color to blue, save it. I'm going to leave it open because I'm probably going to have to go in and look at these dimensions again because we want to do the same exact thing for this part here. So let's open this part, create a sketch, so we're going to create, let's create our line first. Oops. Our line, construction line. Turn off construction geometry, create our two circles. I'm going to use an equals constraint on this one because we ended up making them the same. Dimension 1 to be 0.6. Let's center the line on the origin using a vertical constraint. So the center point of the line to the origin. The dimension from the center, from the line to the end of the flange was 0.7. The length of the line was 0.8. Oops, I made a typo. 0.8. Finish the sketch. Use the cut tool. And I'm just remembering these dimensions off the top of my head just because I've gotten used to remembering dimensions through working with CAD. So it's a good idea to write them down if you can't remember them. But for the sake of the video, I'm just doing them in my head because it's faster. Okay, so we're going to change the color to blue and close both of these. And if we go to the bottom, we can see that these don't line up. Oh, right, they're not going to line up. Duh. They're going to be different because this bracket is inwards. Now, if you cared, which there's no reason to, if you cared that these holes lined up just for maybe aesthetics, you could move these holes out, but you just, once again, you can't get too close to a bend. With this thickness of material, you need like 3/10 of an inch minimum, which we've got about 4/10 between here and there. So, I mean, that's plenty. But if you get too close, basically, the hole will start to warp and it'll interfere with the bend on the press brake. So you've got to keep your holes away. Small holes like these typically aren't an issue, but big lightning holes like this definitely are. All right, so let's we're done with those parts, and you can see as we finish parts and we set the color, we can kind of get a sense of what needs to be done yet. All right, let's do these outer parts here. Let's do this lightning pattern here. Now I haven't really quite decided exactly what we're going to do. I'm going to do something pretty simple just for the sake of time. So let's create a sketch. There's a specific lightning pattern that we use on Stellar because it basically looks cool. I'm not going to use it here though, just like I said, for the sake of time. So what I'm going to start off by doing is I'm going to pick a 2-point rectangle, turn on construction geometry, and create this rectangle here. So we've got a square bearing block here. We don't want our lightning pattern to interfere with that. We know the bearing block is 2 inches square, so we're going to set the edge of this line even with the edge of the bearing block. Actually, I'm going to come back to that. All right, we're going to dimension this end here to be, we're just going to add a 1/2 inch all the way around and see what that looks like. And then from here to here, we're gonna add. It's gonna be 1 inch, and then we're gonna do another 1/4 of an inch beyond the gearbox just for some buffer space. We're gonna do 4/10 of an inch here. I'm just doing this visually. I haven't done this part before, so I'm actually doing it for the first time here on video. So I'm just kind of figuring out some of the dimensions. We're gonna do 4/10 all the way around. You need about 3 for the press brake, but I want a little bit more meat than that. And then basically what I'm going to do is I'm just going to create like an X. We're going to leave an X in here and cut out all the other material inside of this shape. So I'm going to take this line and turn it on because we're going to use it. I'm going to take this line and turn off the construction geometry, so these are actual like real lines now. Then basically what I'm going to do is I'm going to pick this line. I'm going to draw, oops, I'm going to undo that with Control Z and turn off construction geometry. All right, line. Start at this corner, go to here, and connect back to there. Do the same thing on the other side. So we've got 2 triangles. Then I'm going to create a line that goes across like this, and a line that goes across the bottom like that. Then I'm going to make 2 triangles here as well. You need to be careful that this doesn't start inferring constraints because you need to be able to go back and add constraints. If when you start constraining this, Inventor starts telling you adding this constraint will over-constrain the sketch, which I'm sure is going to happen to some of you, press F8, and if there's any constraints that you don't think should be in there, like parallel constraints or or horizontal constraints or something, just right click and delete them. Now in this particular case, we want these. These should be here. Doesn't look like I got any constraints that I didn't want. However, if you do, you can press F8 to turn on these icons, delete the ones you don't want, and then press F9 to hide them again. Okay, so we're gonna make all of these parallel with their partners to make a nice X pattern. So let's do a parallel constraint between this one and this one. These two. All right, now basically I want these to line up like across from each other. So I'm going to use a collinear constraint to constrain this one and this one to be collinear, and this one and that one to be collinear, and then this one and this one to be collinear, and this one and that one to be collinear. So now basically we can adjust. We've got some flexibility here, but we need to kind of adjust sizing and stuff. So let's set the thickness of this web. We're going to cut out these triangles basically. So let's dimension these to be 1/4 of an inch, and same thing for this. And because we have those collinear constraints, we only need to do 1 dimension for each side. Alright, so because of all those constraints, everything's fully constrained now, so we can finish the sketch. Then we can use the cut tool, pick these 4 regions, and click OK. Now we don't want these sharp corners here, plus they look kind of funky, so we're going to go to the corner round feature. We're going to set a smaller radius of like 1/8. We might change that. Click on 0 selected. Pick every corner in the lightning pattern. Okay. Alright, so that looks a lot better. And this part's done. That removes some weight, not a lot of weight. This part's pretty small, but you know, any weight you remove is good. So we're going to set this color to blue, give this a save, and close it. All right, and it's starting to look pretty cool. So we've got one part to do. We're going to do basically exactly the same thing. The lightning pattern is going to be, well, it's going to be exactly the same. So let's just open this part, do the same exact thing again. So we're going to create a sketch here. We're going to turn on construction geometry, turn on our rectangle tool, make a rectangle, turn off construction geometry, measure dimension from the center of this hole to this side of the rectangle to be 1.25, you know, 1 inch plus another 1/4. To the end is going to be 0.4. Now the top is not going to be 0.4. I mentioned we need 0.3 minimum, but because this part is overall a 1/16 inch shorter on either side, I'm going to go ahead and do 0.4 minus a 1/16 so that the lightning pattern is the same size as the lightning pattern in the part across it. That'll just help it look a little bit better. Then I'm going to do the same thing on the bottom. So it's going to be 4/10 minus a 1/16. Alright, so now I'm going to select both of these and turn off, turn those to standard geometry. Then I'm going to go through, construction geometry is off, going to make my triangles, going to make my horizontal lines across the top, and turn those into triangles. Then I'm going to go through and add my parallel constraints. Then I'm going to add my collinear constraints to opposing pairs of lines. Alright, now I'm going to dimension the width of the X to 1/4 inch on either side. Now we're fully constrained. You notice everything turned blue, so we can finish the sketch. Go to cut. Cut out those 4 regions, go to corner round, set the radius to 1/8 of an inch. Go back to selection mode, pick all the corners. Great. Alright, so now this part's done as well. Oops, what did I click? Okay, click the drop down, set the material to blue, give it a save, close it. Alright, so that we are done for the structure here. Trying to get a good view here. You can see here, you know, the lightning pattern is the same on both sides, so it looks pretty cool. This is not actually the lightning pattern that Stellar Robotics uses. We have a slight variation to this. It's similar, but there's a slight variation. I'm not going to go into it because it's a little more complicated. But, you know, those of you who are working on the robot CAD, I'll show you how to do it. And then you'll know. All right, so the next video, we're going to go through and add fasteners. We're going to add spacers. We're going to add the washers and screws on the end here. We'll add the gearbox mounting screws. We'll add the spacer in here. That should be it, and the screw on the end. So there's not going to be much, but we're going to just go ahead and put the stuff in. Like I said, we're not going to do rivets because that would just be obnoxious. All right, thank you for watching, and I'll see you in the next one.